Hello, hello, and welcome back to another wonderful day of pre-calc. Today we're going to be talking about solving equations, specifically those pesky radical equations. And yeah, it's going to be fun. So radical equations are equations that have radicals in them. There's a couple different ways that these guys can get set up. Sometimes you can have a radical is equal to a radical. This is usually solved by either squaring or cubing or fourthing or whatevering both sides of the equation to get rid of the radical, and then you just solve the equation like you'd normally solve an equation. Just FYI, we'll get there. So you solve the equation, don't forget to check the solution. Because if you ever get a solution that causes a negative number inside of an even radical, well, then it doesn't have any real solutions. And you'll have to check your directions. Sometimes they say, please write your answer in your complex answers in simplest form, or as complex numbers in its simplest form, or something along those lines. And so that can kind of clue you in, okay, I can have i's in this case. Or it'll say, please write your all real solutions, in which case, oh, real solutions, that means if I end up with a negative inside of the root, that means there's just no solution because there aren't any real solutions. Just kind of got to check your directions. Okay. So this guy right here, our first one, both sides is a cube root, which is beautiful. So we're just going to cube both sides. Bada bing, bada boom. We're left with 2 minus 4a is equal to 2a minus 1. So that becomes 3 equals 6a. And divide both sides by 6. And we have 1/2 is equal to a. Bloop. Well, this is a cube root, so chucking it back in, even if we end up with a negative, it's perfectly fine. So we're good to go. Well, 2 minus 4 times 1/2 is 2 minus 2, which is 0. 2 minus 1/2 minus 1, 1 minus 1, which is 0. Okay, yes, it checks out. All right, this one is an oops, and it's a deliberate oops. I accidentally assigned an assignment like this on homework once where the cube was on one side and the fourth was on the other side. Technically, officially, what you would do is go, okay, what is the least common multiple of 3 and 4? That's 12. So you would raise both of these sides to 12. But then you're going to end up with some complicated polynomial jargon, blah, 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 and that's beyond the scope of this particular lesson. So that's an oops. We're just going to change that to a 3. And cube both sides. So much easier. Or we could have changed the other one to a 4. So yeah. If you run into something like that on your homework, check with your teacher and make sure that they actually meant for you to have to raise something to the 12th power. Because at this level, probably not. But you never know. Some teachers are really adventurous and think very highly of their students and think that that's a totally legit thing to be doing during the first month of class. Kudos to them. Negative 32, divide by 4, and k is equal to negative 8. Chucking that back in, 2 times negative 8 plus 24 is negative 16 plus 24, which is a positive 8, perfectly fine. Negative 8 minus 2 times negative 8 becomes negative 8 plus 16, which is positive 8, also perfectly fine. Even if those had been fourth roots, these are positive numbers, so we wouldn't have run into the weird thing where we have a negative number inside of an even radical, and we're golden, we're good to go, we can move on. Next type, we have a single radical. So on the previous one, we had 2 radicals were equal to each other. This one, we've got a radical floating around in the midst of a whole bunch of other stuff. We're going to treat these kind of like we did with the absolute value equations, where we try and get the radical by itself, treat it as if it was one big variable, get it by itself, and then undo the radical by either squaring or cubing or whatevering both sides of the equation, and then solve the resulting equation, and as always, check for extraneous solutions because we don't want a negative inside of a square root. Blah, 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 blah. All right, we got a few more examples going on here. So I'm going to scoot this over just a little bit because then it's more comfortable for me to write on it. Negative 9, square root 4g plus 13 is equal to 5. Square both sides. 4g plus 13 is equal to 20. That is not supposed to be a 24. I do not know where the 4 was coming from. 4g is equal to 12, g equals 3. Checking that back up in here, 4 times 3 plus 13 is going to be 12 plus 13, which is 25, which is a perfectly acceptable thing to have inside of a square root. And that's as much of the checking that you really need to do, because that's what we're really concerned about. Am I putting a negative inside of a square root? Okay, this guy is pretty straightforward. We're just going to square both sides. And that's going to give me 18 minus 7x is equal to x squared. Ah, gosh darn it, there's a quadratic. Okay, it's okay, it's okay. 0 equals x squared plus 7x minus 18. So what multiplies to a negative 18, but adds to a 7? Positive 9 and a negative 2? Yes, there we go. X plus 9, x minus 2. Then we split this up into two different equations. X plus 9 equals 0, 0 equals x minus 2. And we end up with x equals negative 9, x equals positive 2. I do need to check these to make sure that neither one of these is going to end up with a negative inside of the square root. So 18 minus 7 times negative 9, 18 plus 63. I don't know what that is, but it's positive. 18 minus 7 times 2 is 18 minus 14, which is a positive 4. They both check out. So we're going to use our curly brackets because we have multiple answers. And there we go. Whew. All right, last but not least, for this particular type, we're going to square both sides. And we end up with, oh my goodness, p squared minus 14p plus 49 equals 8p minus 63. For those of you, this is really p minus 7 times p minus 7. Please don't forget your OI, or your middle term, because you do end up with p squared minus 7p plus 49. A lot of times people forget about this guy, so just, you've been told. Now we're going to combine like terms. P squared minus 22p? Yes. Yeah. Plus, oh dear, 3 plus 9 is 12, 112 equals 0. Oh my goodness, what multiplies to 112 that makes 22? Ugh. I honestly don't want to think about that, so I'm going to quadratic formula this. A equals 1, B equals negative 22, and C equals 112. It's a perfectly valid strategy. Was there something simpler? Possibly. That might be factorable. I don't know. And I don't really feel like figuring that out. So negative 22 plus or minus the square root. Oh, but now I have to square negative 22. Minus 4 times 1 times 112 over 2 times 1. Still worth it. 22 plus or minus the square root. 22 times 22, 44. So that'd be 484 minus 4 times 112 is 844. All of that over 2. 22 over 2 plus or minus whatever the mess this turns into. Minus 448. That'd be a 6. 7 minus 4 is 3. Oh, it's going to be a 36. That's delightful. 11 plus or minus 6 over 2 equals 11 plus or minus 3. So 11 plus 3 is 14. 11 minus 3 is 8. So those are my two potential solutions. Again, I still, after doing all of that work, need to check them out. So 8 times 8 minus 63 is 64 minus 63. That's a positive. That one's okay. 8 times 14 minus 63. I don't know what 8 times 14 is, but it's some big, huge positive number. So that should be fine. I feel like I messed up somewhere. Because I thought I set this up so at least one of these solutions didn't work, but I guess it didn't. Okay, moving on. Boop. Up. There we go. The last thing we want to talk about is rational exponents, because that's another thing that we talked about when we talked about radicals. And basically, you're going to isolate the expression with the power on it. So the parentheses, get the parenthesis things by itself. And then you're going to raise each side of the equation by the reciprocal exponent. Reciprocal means flip over the exponent. So it's a fraction, flip it over, make it the reciprocal, and then make that the exponent on both sides of the equation and simplify the ensuing craziness. Basically what we're doing. All right, so we have 6p minus 23 to the 1/2 is equal to 5. So the reciprocal, if I take 1/2 and I flip that over, that's really 2 over 1. So I'm going to take this whole thing and I'm going to square it. I'm going to take this whole thing and I'm going to square it. So the squared and the 1/2, they cancel each other out because the whole reason of doing this is anything raised to an exponent, I then have to multiply the exponents and it cancels out and I just left with an exponent of 1, right? So then I can just ignore the exponent because everything has an exponent of 1. We don't really care about exponents of 1. 6p equals 48. Divide both sides by 6. P is equal to 8. Still worth checking your answer. I want to make sure that I'm not putting a negative number inside of a root. 48 minus 23 will be a positive number so we can move on with life. Okay. And this one, if I take 2/3 and I flip it, I end up with 3/2. So 5v minus 22 equals 4 to the 3/2. 4 to the 3/2. That's the same thing as the square root of 4 being cubed. So 2 cubed, which is 8. So 5v minus 22 equals 8. 5 volts equals 30. And v equals 6. So this guy has the 3 as his radical exponent, radical root, something like that. So not really concerned about the negatives here. It's good practice. So 5 times 6 minus 22 would be 30 minus 22, which is 8. So I'm good to go. And that is my answer. All right. Always check your solutions. Assume that we're working with real numbers unless the directions specifically say that you're working in the complex number system. Assume that you're working with real numbers and that you need to then make sure and check that you don't end up with a negative inside of your square root, or your 4th root or your 6th root. All of those are no good, bad news. Our next video, we're going to be talking about solving equations, but specifically rational equations instead of radical equations. Radicals are the ones with the roots. Rationals are the ones that look like fractions. And that's it for today. Make sure that you look back through your notes, make sure everything makes sense, and don't forget to fill out your wonderful, friendly video reflection form. Happy math!